Welcome to your another session of your online classes. Children, just to remind you that we are studying lesson number 10, Gravitation, and today is the second part of the lesson. Children, today what I am going to teach you is a very important concept. So that is why I have made today's lesson a very small lesson video. Now, children, in my last slide, I asked you and I had shown you a picture and I asked you what next. So, children, I hope you all remember that story where Newton was sitting under a apple tree and suddenly an apple fell on him, and this led to the formation of a this law, Newton's universal law of gravitation. So let us understand what is it and why it is called as a universal law. Now, this particular law was suggested by Sir Isaac Newton. According to this law, according to this law. Now, children, look here, look in this particular picture. You can see two objects. Now, these two objects can be anything. They can be two stones. It can be you and your television. It can be sun, moon. It can be any two objects. So, let us understand any two objects. And these two objects are separated by a distance d. Let us consider that mass of one object is m1 and mass of another object is m2. Now children, these are not any fixed value. So if you wish to change this object as m1, you can do that. No issue in that. Understood? So what does Newton's universal law of gravitation say that that let let us consider any two objects which are separated by a distance d. Understood? And having a mass m1 and m2 respectively. Now, in this particular case, okay, the force of gravitation is directly proportional to the. Now, what does the law say is that? Understand. Every object in the universe attracts the other object with a force. Now, this value of force is directly proportional to the product of their masses and inversely proportional to the square of distance between them. And always remember that the force acts along the line which is joining the two bodies. Again, look at this picture. So children, you can see these two arrows. These two arrows can be considered as a line which is joining them together. Understood? Now, let us understand it in a better way with the help of this particular diagram. Okay, children, let us consider two objects P and Q, which are separated by a distance d. Okay, and this distance we represent here by r. So let us consider the mass of the object P is capital M and the mass of Q is small m. Understood? So what happens next? Let us understand. You can understand this particular concept with this diagram also. This is our earth, children, and it can be moon. So the force of attraction between them can be calculated in this way also. So this is m1, this is m2, and you can see the distance r. Okay, let F be the force of attraction between the two objects P and Q. Now, according to universal law of gravitation, the force of attraction between them is directly proportional to the product of their masses, capital M and small m. Okay, and the force is inversely proportional to the square of distance between them. Okay, now inversely proportional means 1 upon r square. Okay, now children, when we combine both these two equations, what do we get? We get F is directly proportional to the m1 multiplied by m small m divided by r square. Now, children, this sign of proportionality, whenever we remove it with the sign of equality, a constant comes in the picture. Okay, I hope I taught you one constant in Newton's law of motion in the second equation, F is equal to ma. So there we used k. So in that particular law, children, the value of k was 1. Okay. Now in this particular equation, we remove this sign of proportionality by a constant capital G. And children, this capital G is known as universal gravitation constant because its value remains constant irrespective of any heavenly body you talk. You can talk about any planet, you can talk about any satellite, you can talk about any stars, anything that you must have observed when you studied about lesson number 20 in 8th standard about stars and planets. Okay, so this particular value of G always remains constant, and children, the SI unit is very important. Now how we have derived this SI unit, let us understand. Okay, now the SI unit of force is mass. Okay, the SI unit of distance or radius is m square and mass is kg square. So this is how we got the SI unit of capital G. We call it as capital G because in my coming up lesson I'll be teaching you about small g. Okay, these are the words that you must have studied in your very previous classes, LKG, UKG, but here we will be studying capital G and small g. So capital G, always remember, is known as universal gravitation constant. And children, there was a Russian scientist Henry Cavendish, okay, and he was the first person to calculate the accurate value of capital G, and it is 6.673 into 10 to the power minus 11 Newton meter square upon kg square. Now, you can use this value as 6.67. You remember in Avogadro's concept also I told you, you can write it as 6.22 or also you can use it as 6.23. Both are correct. So children, ultimately our law is given like this: F is equal to G m1 upon m1 multiplied by m2 upon r square. This force of attraction is directly proportional to the product of their masses and inversely proportional to the distance square of the distance between them, and this is capital G, which is known as universal gravitation concept. And finally it comes out to be like this: the force of gravitation between any two objects having mass m1 m2, it is represented like this. Okay. Now children, I hope you must have understood this. Now in my coming up lessons I'll be taking importance of gravitation, and then children, we will study numericals. And one good news is that very soon I may start your live classes also. And thank you. Take care of yourself, children.